We are going to see the methodology for capacity calculation. Usually, to calculate the airport capacity there are empirical methods, queuing models many times mixed with analytical models, or computer simulation methods. Empirical methods collect statistics from many flights and from that, obtain a few graphs or formulae that will enable us to predict the capacity as a function of mix, departures, etc. Queuing and analytical models are based on formulae, and computer simulation is based on creating a system that, based on a clock, or by the Monte Carlo method, a statistical method, simulate the airport operation. Here there are their advantages and disadvantages. Normally, the analytical is simpler and quicker because there is no need to collect a lot of data to do the simulation, then we will see the data that is necessary. However, on the other hand, it gives us less accurate results, but that may be valid for a preliminary analysis. Many times, for a preliminary analysis people spend a lot of money and time to do a simulation with SIMMOD, for example, when actually it might not be necessary. A simulation could be done with a simpler analytical method and then, for a closer design, work with a simulation of this type. Simulations may use Monte Carlo method, which is based on dropping random points in different locations and then studying how the system works, or event simulation, which is more common. For instance, SIMMOD, an FAA model which was developed in the 1980s and after that has evolved, featuring a complex GUI in commercial software. It works on the basis of files for event, for nodes, etc. Another FAA model is the Airfield Capacity Model, which is a 1970s model. It has graphs and a quite old program, that is quite easier to use. A simulation requires a series of preparations that cost money, that take a long time and are a waste for a one-time thing. Once you have an already working airport simulation model, what would be recommendable is to devote resources to keep it so that what-if analysis can be performed. What if separation is reduced? What if we acquire a precision radar? If we have an active model we can do this kind of simulations. Here you have, for example, the SIMMOD in a URL where you can see some videos of how it works, how the aircrafts move in the apron and in the airspace. How does SIMMOD work? Well, it compares the system operation with the operation of a restriction-free system, that is, what would be the capacity of a restriction-free system and what percentage we achieve. For that, it uses several files, an airspace one which contains all the nodes for each aero route, links, also the separation scheme, procedures, etc. Another land file with the airport nodes, boarding gates, time to attend each boarding gate. And another external events file. It is based on discrete elements and simulates the movement of the aircraft between the various nodes. For that, it uses a simulation clock and an event manager. Airports and airspace are node networks. It requires the programming of flights, aircraft flight performance, ATC rules and procedures, air routes, the distribution of the airport and land procedures. To summarize, a lot of information is needed for feeding the model. In exchange, we have a more accurate simulation. Here you have, for instance, the events. We can incorporate random variables to say the time it takes to onboard an aircraft and assist it. It might vary between certain values, and then there are internal and external generated events. External events can be about beginning flights, departures, arrivals. Internal events are about the aircraft going from one to another point. The events that modify the simulation parameters can include, for instance, meteorology and so on. External events can also generate data outputs, for example, the beginning of a flight or its definition. For instance, flight AA234 arrives at node 120 at 11:40. Flight TW11 finishes loading at gate S12 at 11:42. Flight CO888 arrives at node 320 at 11:44. Those are events that update the system. Another software used for such things is AirTOP, used by Eurocontrol to optimize air traffic, RAMs plus for ATC and airspace studies. Jeppesen's TAAM, we will see a screenshot, for the study of a terminal, and similar to SIMMOD, CAST for the integral management of airport terminals. Here we have a TAAM video. It is similar to SIMMOD but with a cooler 3D model. And here we have CAST. It can simulate the runway, terminal area and baggage carousel to simulate the terminals. Well, this concludes the